Alright, so today I want to talk about Newton's third law, and I'm just going to give a brief description and also give some examples and some application to our everyday life. So, first thing I want to go over is the clear definition. And Newton's third law basically states that for every action, there's going to be an equal and opposite reaction between two objects. And this part is really important because you're going to need to know that a third law problem is always going to have two objects involved exerting a force on one another. This is the most important part if you want to recognize third law problems, because you definitely are going to get those. But now I want to give a quick example of where you can see Newton's third law in your everyday life. So I'm just going to start that you're sitting in a chair, and those are just the wheels of the chair. And let's say you're also wearing socks. And the reason why I say you're wearing socks is because socks have low friction, which means you're going to be able to move across the floor easier. And let's say you pull a desk towards you. So you're pulling this desk towards you to the left with the force of 40 newtons left. So you're pulling the desk 40 newtons left towards you. And basically what Newton's third law states that for every action there's going to be an equal and opposite reaction between two objects. Two objects here are you and the desk. And there's going to be the same force, but they're acting on two different objects. And that's why they won't cancel out. That's why there's going to be something that happens here. So when you pull the desk towards you, you're going to notice that your chair actually moves forward when you push the desk. When you pull the desk towards you. And that's a clear example of how, well, the equal and opposite reaction. The desk is actually exerting a force of 40 newtons to the right after you pull the desk 40 newtons left. So as you pull it 40 newtons left, then the desk is pulling you 40 newtons right. And that's just like a clear example of how Newton's third law applies. Well, you could probably see that if you tried that right now. But another example that I want to show is if you're on a skateboard. And then you see a wall ahead and you don't really want to crash into the wall. So what you do is you have your hands out ready to push off. Eventually you do get to the wall. And then you push off the wall. You push the wall with a force of 20 newtons forward. And so you push the wall with the force of 20 newtons forward. Well, you're going to notice that after you push the wall with 20 newtons of force forward, then your skateboard is going to start accelerating the other way. And most people would just say, "Oh, it's just because I pushed off of it," and yeah. But if you want to go into further detail, that's the clear example of the equal but opposite force in the opposite direction, and that's basically just saying the wall is pushing back on you with a force of 20 newtons, same magnitude but opposite direction, and that's what causes you to accelerate the other way after you push off the wall due to Newton's third law. And there's a lot more examples of this, like when you jump. when you're jumping off the earth, okay, when you're jumping off the earth, your legs or your feet were pushing down on the earth to jump, right? And then the earth pushed that force that you were jumping right back up to you, which is what makes you go up in the air. Another thing you can see is, um, particularly with rockets, see the gas shoots backward, but the rocket moves up, which shows directly how Newton's third law works, because once the gas is burned, the fuel is burned, it creates high speed gas. The gas is pushed out backwards, which causes the rocket to accelerate upwards. And those are just some examples of Newton's third law. So yeah, that's it.